In the first question, we are given the differential of fx and we are asked to find fx. Okay, so we'll have to integrate this differential in order to find fx. So let's begin. First we'll write fx is equal to, and then we'll integrate it. So 2x raised to the power minus 1 upon 3 plus 1 is equal to 2 upon 3 divided by 2 upon 3 minus x raised to the power 1 upon 3 plus 1, which is 4 upon 3. 4 upon 3 divided by 4 upon 3 plus c, which is for the unknown constant. This represents the unknown constant. Okay, so now simplifying it, we get 3x raised to the power 2 upon 3 minus 3 upon 4 x raised to the power 4 upon 3 plus c. Now we have to find c, which is the unknown constant. To find c, we can replace x with 8. Since we are told that when x is 8, y is equal to 5. So we can say that 5 is equal to 3 multiplied by 8 raised to the power 2 upon 3 minus 3 upon 4 multiplied by 8 raised to the power 4 upon 3 plus c. Okay, so now 8 raised to the power 2 upon 3 is 4, and 4 multiplied by 3 is equal to 12. 8 raised to the power 4 upon 3 is 16, and 16 multiplied by 3 upon 4 is 12 again. So we have 5 is equal to 12 minus 12 plus c. Now 12 minus 12 will cancel and c will be equal to 5. Okay, so now we have we know what c is. C is equal to 5. We had to find fx. Now we can easily write that fx is equal to 3x 2 upon 3, 3x raised to the power 2 upon 3 minus 3 upon 4x raised to the power 4 upon 3 plus c, which is 5. So this is fx. Moving on to the next question. Okay, so in question number 2, we have a curve and a straight line. We are given their equations. We have to find the set of values of c for which the curve and line intersect at two distinct points. Now, whenever we are given a question where there is a curve and there is a line and they intersect at two distinct points, or they intersect at a single point, or they do not intersect at all, one thing which comes in our mind is that we have to use the discriminant, which is b square minus 4ac. Now, since we are told that the curve and the line intersect at two distinct points, this means that the discriminant must be greater than 0, which means b square minus 4ac, which is the discriminant, must be equal greater than 0. Okay, so now we know y is equal to x square plus 2cx plus 4, and y is also equal to 4x plus c. So we can simply write x square plus 2cx plus 4 is equal to 4x plus c. X square plus 2cx minus 4x plus 4 minus c. Okay, now we have x square plus 2c minus 4x plus 4 minus c. Okay, and it is equal to 0. Okay, so now this equation is basically in the form ax square plus bx plus c. Okay, So in this case, our a is equal to 1, since we have x square and x square is 1x square basically. So our a is equal to 1, our b is equal to 2c minus 4, and c basically is equal to the place in this equation is equal to 4 minus c. So our discriminant is b square discriminant is b square minus 4ac. Okay, so 2c minus 4 whole square minus 4, a is equal to 1, c is 4 minus c. This thing is greater than 0. Now simply simplifying this, expanding, 2c minus 4 whole square is 4c square minus 16c plus 16 minus 16 plus 4c is greater than 0. Okay, then 16 minus 16, this will become 0. Then we have 4c square minus 12c. This is greater than 0. Okay. Now 4c, taking 4c as common, and then we'll have c minus 3 is greater than 0. Okay, now for a moment, forget this inequality. If there was an equal to sign and we had 4c bracket c minus 3 is equal to 0, then we would get two answers. One would be c is equal to 0 and the other answer would be c is equal to 3. Now we will get the exact same answer with this inequality, except that we will have to we can't use the equal to sign. We'll have to use an inequality. Either it will be less than or it will be greater than. Now an easy way of finding out whether it will be whether we will have to use a less than sign or a greater than sign is simply to draw a graph, and the graph will be a minimum one since it is greater than 0, and our graph will be a minimum one. Okay, now we have two answers, one is 0 and one is 3. So we'll mark 0 and 3. Now suppose there is a graph and we are asked to find the values for which the values of x for which y is positive. Okay, this is the y-axis and this is the x-axis. So we can obviously say the values for which y is positive is when x is less than 0 and when x is greater than 3. In this case, we'll have the answer c is less than 0 and c is greater than 3, because we have to find the values of y which are greater than 0, and in this case y is greater than 0 when c is less than 0 or c is greater than 3. So we have the answer c is less than 0 or c is greater than 3. Moving on to question number 3. Find the term independent of x in each of the following expansions. Okay, so now we have to find the term independent of x. When using binomial theorem and expanding, we write this as NCR. Whatever term we have in the first place, in this case it is 3x n minus r, and the second term, which in this case is 2 upon x square r. Okay, so this is how we expand it. Now we have to find the term independent of x. The term independent of x means the term where x has the power 0, where x is raised to the power 0. Now we have to find the term where x is raised to the power 0. An easy way to do this is simply to use this method of expanding and write 6cr. Let's just erase it. 6cr 3x 6 minus r 2. Since this is x 2 upon x square, we can simply write this as 2x raised to the power minus 2 raised to the power r. Okay, now we have to find the term independent of x. As I said earlier, this means the term which is raised to the power the term in which x is raised to the power 0. For a moment, just ignore the numerical values. Okay, so we know this will be a numerical value. Ignore 3 as well and ignore 2 as well. Now simply multiply x 6 minus r with x minus 2r. Okay, so 6 minus r minus 2r is equal to 6 minus 3r. X raised to the power 6 minus 3r is equal to x raised to the power 0. And we can simplify this by writing it like this. And we'll have the answer will be equal to 2. Now we will put r in the form NCR, and we'll simplify it, and we'll get the term independent of x. Okay, so 6c2 3x 6 minus 2 is 4, 2x minus 2 2. Okay, so 6c2 is 15 multiplied by 3 raised to the power 4 is 81, x raised to the power 4 multiplied by 2 raised to the power 2 is 4, and x minus 2 raised to the power x minus 2 squared is x raised to the power minus 4. So this will simply cancel out. 81 multiplied by 4 multiplied by 15. So the answer will be 4860. So 4860 is the term independent of x. Moving on to part B. Okay. So we have to find the term independent of x. We already have a term which is 4860. Now, an easy way to solve this question is, we know 4860 multiplied with 1 is equal to 4860, and this is a term independent of x. Now, since there is x cube, we must find a term we must find a term in which x has the power minus 3, because when this x raised to the power minus 3 is multiplied with this x raised to the power 3, we'll get a term which is independent of x raised to the power 0. Okay, so now we have to find a term where x has the power minus 3, x is raised to the power minus 3. Okay, so using the same method, 6cr 3x 6 minus r 2x minus 2 r, and now x must be equal to minus 3, since we have to find a term in which x has the power minus 3. Again, ignoring the numerical values, x 6 minus r multiplied with x power minus 2r and equating it with x minus 3. Then simplifying this equation, 6 minus r minus 2r is equal to minus 3. Okay, so we have 6 minus 3r is equal to minus 3. Okay, this means r is equal to 3. Okay, now we have to put this value of r is equal to 3 in the NCR method, and find out the term where x has the power minus 3. So 6c 3x, 6 minus 3 is 3, 2 upon x square raised to the power 3 . Okay, so 6c3 is 20 multiplied by 3 raised to the power 3 is 27, x cube multiplied by 2 raised to the power 3 is 8 upon x power 6. Okay, so 20 into 27 20 multiplied by 27 multiplied by 8 is equal to 4320, and this x power 3 will cancel out this and we'll get x cube, and we have the answer x power minus 3. Okay, now we have to find a term independent of x. Okay, so our answer in the previous part was 4860. This was a term independent of x. Now we can simply write 4860. Okay, 4860 plus 4320 x power minus 3 plus dot dot dot. Now we are writing these dots to indicate those terms that we have ignored, which we don't need. So we can simply write 3x plus 2 upon x squared raised to the power 6 as this thing, and then we have to multiply it with 1 minus x cube. Okay, so now we know 4860 multiplied with 1 is 4860, and 4320 x raised to the power minus 3 multiplied with minus x raised to the power 3 is minus 4320, and subtracting 4860 and 4320 we get the answer 540. So the term independent of x is 540. In this question about arithmetic and geometric progression, we have to find the sum of the first 20 terms of the arithmetic progression in terms of a. Now we are told that the first term of a geometric and arithmetic progression is a, and the third term of geometric progression is equal to the second term of arithmetic progression, and the fifth term of geometric progression is equal to the sixth term of arithmetic progression. Now the formula for arithmetic progression is a plus n minus 1 multiplied by d, where a is the first term, d is the common difference, n is the term we are talking about, and the formula for geometric progression is a r raised to the power n minus 1. A is the first term, r is the common ratio, and n is the term we are talking about. Now the third term of geometric progression is a r, n is 3 in this case, so 3 minus 1 is equal to 2, ar raised to the power 2, and this is equal to the second term of the arithmetic progression. Now in the second term of arithmetic progression, n is 2, so 2 minus 1 is 1, and we have a plus d. Okay, now the fifth term of geometric progression. The fifth term of geometric progression is ar, and since n is 5, so 5 minus 1 is 4, ar raised to the power 4. It is equal to the sixth term of the arithmetic progression. The sixth term of arithmetic progression means n is equal to 6. So 6 minus 1 is 5. So a plus 5d. Okay. Now we have to eliminate r. When we eliminate r, we will get the answer for d. We will know what d is. We will find out the value of d in terms of a. After finding out the value of d, which is common difference, we can easily find the sum of the first 20 terms of the arithmetic progression in terms of a. Okay, so r square is equal to a plus d upon a. Now we can use this value for r square and substitute it here. Okay. So since this is r raised to the power 4, it is same as r square into r square. So we can say a multiplied by a plus d upon a plus d upon a. The difference is that this is the value for r square, and we have and here we have r raised to the power 4. So we have a difference of power 2. So we'll simply write that a plus d upon a whole squared. This is equal to a plus 5d. Okay. Then a multiplied by a plus d whole square upon a square. So this cancels its power 2, and we have power 1 remaining. This is equal to a plus 5d. Now expanding a plus d whole square, we get a square plus 2da plus d. This is equal to a square plus 5da. Sorry, I forgot to write square. A square plus 2da plus d square is equal to a square plus 5da. Now a square will cancel out a square, and we have d square is equal to 3da remaining. Now this d will cancel this d square. We have d is equal to 3a remaining. So d is equal to 3a. D is the common difference. Now common difference is equal to 3a. Now we have the common difference as 3a, and we have the first term, which is a. Okay. So now we can easily find out the sum of the first 20. We had to find out the sum of the first 20 terms of the arithmetic progression in terms of a. Now we can easily find that out. Okay. The formula for calculating the sum of the first 20 terms is, the formula for calculating the sum of an arithmetic progression is n upon 2 multiplied by 2a plus n minus 1 multiplied by d. Here n is the term we are talking about, number of terms, 2a is the first term, n is the number of terms, and d is the common difference. So we can write S20 is equal to n. Now since we are talking about the first 20 terms, n will be 20. 20 upon 2 multiplied by 2a. Since our first term is a, so we'll simply write 2a plus, and n is 20. 20 minus 1 is 19, and d is 3a, so 3a. Okay. Now this will simply be 10, and we have 10 multiplied by, now 19 multiplied by 3 is 57. So we have 57a plus 2a. Now 2a plus 57a. 57 plus 2 is equal to 59. So we have 10 multiplied by 59a. Okay. And 59 multiplied by 10 is 590a. So the answer is 590a. Moving on to the next question. Express 2x square minus 8x plus 14 in the form 2 brackets x minus a whole square plus b. Okay. Now first, we know that we have to factorize this, and then we have to use completing the square method. We have to complete the square. So first we'll factorize it. Taking 2 as common, we have x square minus 4x plus 7 in the brackets. We just factorized it. Now we'll apply the method for completing the square. So we have x minus 4 upon 2 whole square minus 4 upon 2 whole square plus 7. Okay. So 4 upon 2 is 2. So x minus 2 whole square. 4 upon 2 is 2. So minus 4 upon 2 is minus 2. Minus 2 squared is equal to 4. So we have minus 4 plus 7. Okay. So we have the answer x minus 2 whole square Minus 4 plus 7 is 3 plus 3. So this is our answer. 2x minus 2 whole square plus 3. In the next part, we have two functions f and g, and we have to describe a sequence of transformations that maps the graph of y is equal to fx onto the graph of y is equal to gx, making clear the order in which the transformations are applied. Now, if you look properly, gx is, this part is related to the previous part. Actually, we had to express 2x square minus 8x plus 14 in this form, and this was our answer. And now in the next part, we have to describe a sequence of transformations that maps the graph of y is equal to fx onto the graph of y is equal to gx. So first, let's copy down this over here. 2x minus 2 whole square plus 3. Okay. Now we have to describe the sequence of transformations that map the graph of y is equal to fx onto the graph of y is equal to gx. Now, one thing with transformation is that whenever they are applied, we follow the order of right to left. We follow this order. Right comes first, and we move this way. Right to left. Okay. So, if we move right to left, we can easily identify that there is a translation. Okay. And then there is stretch in y direction. So we have a translation and we have a stretch. Now let's find out the translation factor. Okay, so we'll write there is a translation with translation factor . Okay, so 2 in the x direction and 3 in the y direction. So this means 2, 3. Translation with translation factor 2, 3, followed by stretch in the y direction, since this is out of brackets, in y direction with a stretch factor 2. Stretch in y direction with a stretch factor 2. Okay. Now, in question number 6, we have a circle. The circle with equation x plus 1 whole square plus y minus 2 whole square is equal to 85, and the straight line with equation y is equal to 3x minus 20 are shown in the diagram. The line intersects the circle at A and B, and the center of the circle is at C. Find by calculation the coordinates of A and B. Okay, so we have to find the coordinates of A and B. Now we have to simply substitute this equation y is equal to 3x minus 20. We have to replace y with 3x minus 20, and we have to solve this equation and we'll get the answer. Okay, so x plus 1 whole square plus y minus 2 whole square. So y is equal to 3x minus 20, 3x minus 20, y minus 2 whole square, and this thing is equal to 85. Now we have to simplify this equation. So x plus 1 whole square is x square plus 2x plus 1, and 3x minus 20 is 3x minus 22 whole square, and this is equal to 85. So x square plus 2x plus 1, and expanding this equation, we get expanding this 3x minus 22 whole square, we get 9x whole square minus 132x plus 484 is equal to 85. Okay, so x square plus 9x square is equal to 10x square. 2x minus 132x is minus 130x 1 plus 484 is 485. This thing is equal to 85. Then 10x square minus 130x plus 400 is equal to 0. Okay. Now we have the equation 10x square minus 130x plus 400 is equal to 0. And we have to solve for x. Okay. Now we'll use the method of breaking the middle term. We'll factorize it. 10x square minus 80x minus 50x plus 400 is equal to 0. 10x, taking 10x as common, x minus 8 minus 50, taking minus 50 as common, x minus 8 is equal to 0. 10x minus 50 and x minus 8 is equal to 0. So the two answers are x is equal to 5 and x is equal to 8. Okay. Now we have the x coordinates of a and b. Now we have to find the y coordinates. To find y coordinates, we can simply put the value of x in this equation. Y is equal to 3x minus 20. Okay, y is equal to 3x minus 20. When x is equal to 5, so 5 multiplied by 15, when x is equal to 5 multiplied by 3 is 15 minus 20. 15 minus 20 is minus 5. So we have 5 minus 5. We have the coordinates 5 minus 5. And then when x is 8, 3 multiplied by 8 minus 20. 3 multiplied by 8 is 24. 24 minus 20 is 4. And then we have the coordinates 8, 4. Okay. So if you see b, the y coordinate for b must be negative since this is below the x-axis. So the coordinates y coordinate of b must be negative and the y coordinate of a must be positive. Okay. So this is b since the y coordinate is negative and this is a. So we can write a is equal to, a has the coordinates 8, 4 and b has the coordinates 5, minus 5. Here's the answer. Okay. In the next part, find an equation of the circle which has its center at C and for which the line with equation y is equal to 3x minus 20 is a tangent to the circle. So the coordinates for the center of the circle are -1 and 2. So we'll write that the coordinates for the center are -1, 2, and we have to find the equation of the circle which has its center at C for which the line with equation y is equal to 3x minus 20 is a tangent to the circle. Okay, so we have to find equation of a circle which is like this, and y is equal to 3x minus 20 must be a tangent. Okay, So now we must find the midpoint of AB, midpoint of line AB. The coordinates of A and B are 8, 4, 5, minus 5. Okay. So A is 8, 4. B is 5, minus 5. Now the coordinates of midpoint are 8 plus 5 is 13. 13 upon 2 is 6.5, comma 4 minus 5 is equal to minus 1, and minus 1 upon 2 is minus 0.5. So these are the coordinates of midpoint of A and B. Now this midpoint is the point where this line intersects the circle, which means that the distance from the center of the circle to the midpoint of AB is actually the radius. This distance is the radius. So we can easily use the distance formula calculating the radius of this for calculating the radius of the new circle. Okay, so radius is under root 6.5 minus 1 is equal to 7.5 whole square plus minus 0.5 minus 2 is minus 2.5 whole square, and 7.5 squared is 56.25 plus minus 2.5 squared is 6.25. 6.25 plus 56.25 is 62.5 under root 62.5. Our answer is under root 62.5. Now we have to find an equation of the circle. We have the radius, we have the center. Now we just have to write the equation. So the equation will be x, the center is minus 1, 2, the x coordinate is 1. So x plus 1 whole square plus y minus 2 whole square and radius squared. Radius is under root 62.5, so we'll write 62.5. This is our equation. Okay. Now moving on to the next question. In this question, we have to show that sin theta plus 2 cos theta over cos theta minus 2 sin theta minus sin theta minus 2 cos theta over cos theta plus 2 sin theta is equal to 4 over 5 cos square theta minus 4. Okay, so first we'll have to simplify it using the LCM method. Now, if you realize there is cos theta minus 2 sin theta on one side and cos theta plus 2 sin theta on one side. So there is an identity a plus b multiplied by a minus b, and this thing is equal to a square minus b square. We'll use this identity here, and what we'll get in the denominator will be cos square theta minus 4 sin square theta, and in the numerator we'll have sin theta plus 2 cos theta multiplied with cos theta plus 2 sin theta, and minus sin theta minus 2 cos theta cos theta minus 2 sin theta. Okay, so now if you may have already realized that if you use sine and cos, so our working will get a bit untidy. So we'll instead use S for sine and C for cos. S for sine theta and C for cos theta. Okay, so sine theta multiplied with cos theta is sine theta cos theta. So we'll simply use SC. Sine theta plus 2 sine theta. Sine theta multiplied with plus 2 sine theta is 2 sine square theta. So we'll use 2s square. 2 cos theta multiplied with cos theta is 2 cos square theta 2 cos theta multiplied with 2 sin theta is 4 sin theta cos theta. So 4 SC. Okay. Then we have minus sin theta multiplied with cos theta is sin theta cos theta. Sin theta multiplied with minus 2 sin theta is minus 2 sin square theta. Minus 2 cos theta multiplied with cos theta is minus 2 cos square theta. And minus 2 cos theta multiplied with minus 2 sin theta is plus 4 sin theta cos theta. Plus 4 sin theta cos theta. And we have in the denominator we have cos square theta minus 4 sin square theta. Okay, so there is an identity sin square theta plus cos square theta is equal to 1. Now for sin square theta we can write that sin square theta is equal to 1 minus cos square theta. So we'll say that cos square theta minus 4 1 minus cos square theta is our denominator. Okay, and then we'll simplify it. Okay, now in the numerator we have 5 sin theta cos theta plus 2 sin square theta plus 2 cos square theta minus sin theta plus 4 sin theta 5 sin theta cos theta minus 2 sin square theta minus 2 cos square theta, and in the denominator we have cos square theta minus 4 plus 4 cos square theta. So we have 5 cos square theta 5 c square minus 4, same as this. Okay, now we have to simplify the numerator. Okay, so 5 sin theta cos theta minus 5 sin theta cos theta, they will cancel each other out. 2 sin square theta plus 2 sin square theta is 4 sin square theta. 2 cos square theta plus 2 cos square theta is 4 cos square theta, and 5 cos square theta minus 4 in the denominator. Now we have to show that this thing is equal to 4 upon 5 cos square theta minus 4. Now there is an identity sin square theta plus cos square theta is equal to 1. So taking 4 as common and then using the identity here, sin square theta plus cos square theta is equal to 1. 5 cos square theta minus 4. Okay, so sin square theta plus cos square theta is equal to 1. So we have 4 upon 5 cos square theta minus 4, and now we can simply write 4 upon 5 cos square theta minus 4. So we have shown it here. Moving on to the next question, next part. Hence solve the equation sin theta plus 2 cos theta over cos theta minus 2 sin theta minus sin theta minus 2 cos theta over cos theta plus 2 sin theta is equal to 5 for 0 is less than theta, which is less than 180. Okay, so we know that this thing is equal to 4 upon 5 cos square theta minus 4. Upon 5 cos square theta minus 4 is equal to 5. 4 is equal to 5 5s are 25 cos square theta minus 5 4s are 20. 24 is equal to 25 cos square theta. Cos square theta is equal to 24 over 25, and cos theta is equal to under root 24 over 25. Okay, now we are given a range which is 0 is less than theta, which is less than 180, and our basic angle will be 11.5 degrees. Okay, so now our quadrants are, this one is all, this one is for sine, this one is for tan, and this one is for cos. But you must realize that since we have an under root sign here, our answer will be plus minus cos theta must be equal to plus minus under root 24 over 25. So we'll have one angle here and we'll have one angle here. So this one will be 11.5 degree and this one will be 180 minus 11.5 degree. 180 minus 11.5 is actually 168.5 degree. So we have the answers. Theta is equal to 11.5 degree and it's also equal to 168.5 degree. In this question, we have a circle with the equation x minus 2 whole square plus y square is equal to 8 and a chord AB which intersects the positive y-axis at A, and this line is AB is parallel to the x-axis. Now we have to calculate the coordinates of A and B. One thing which you must realize is that the x-coordinate of A is 0 because A lies at the y-axis. The chord AB intersects the positive y-axis at A. So A lies at the y-axis and at the y-axis the x-coordinate is 0. So one thing we know is that the x-coordinate of A is 0. Now if we put 0 in this equation and in place of x, then we can solve for y and we can get the y-coordinate of A. So let's do this. 0 minus 2 square plus y square is equal to 8. 0 minus 2, so minus 2 squared is 4. 4 plus y square is equal to 8. Y square is equal to 4 and y is equal to 2. Okay, so since this line is straight and this line is parallel to the x-axis, this means that the equation of line AB is y is equal to 2 and the y-coordinate of B must also be 2. Now we have to find the x-coordinate of 2. We can easily find out the x-coordinate of 2, now we have to find out the x-coordinate of B, and we can easily find it out if we put 2 in place of y in this equation and solve for x. We will get two values of x. One will be the x-coordinate of A, which you already know, which is 0, and the other answer which we have to find out will be the x-coordinate of B. So let's put 2 in place of y and solve this equation. Okay, so x minus 2 whole square plus 2 square is equal to 8. Expanding x minus 2 whole square, x square minus 4x plus 4 plus 4 is equal to 8, and x square minus 4x plus 8 is equal to 8. X square minus 4x is equal to 0. Taking x as common, and in the brackets we have x minus 4 is equal to 0. We have two answers, x is equal to 0 and x is equal to 4. Now we already know that the x coordinate at A is 0, and now we found out that the x coordinate at B is 4. So the coordinates of A are 0, 2, and the coordinates of B are 4, 2. Let's move to the next part. In the next part, we have to find out the volume of revolution when the shaded segment bounded by the circle and the chord AB is rotated through 360 degree about the x-axis. Now one thing which you must know is that when we have to find out the volume when a shaded segment or any shaded thing is rotated about the x-axis, the basic formula is basically we multiply pi with the integral of Now we have the shaded segment is rotated about the x-axis. So the limits must be the x-coordinates of the x-coordinates. And in this case, the limits are b and a. And here we have to integrate y square. Okay. So basically the shaded area is this thing. And we are rotating this about the x-axis. But if we use the x-coordinates of a and b, then we are finding out the volume when this whole thing is rotated, which I have outlined. So this extra thing, we are also finding out this rectangle shapes volume. And this rectangle is in 2D, but in 3D, this thing is a cylinder actually. So we'll have to subtract the volume of the cylinder once we find out once we get the value of this volume when we integrate it. Okay, so y square. First we have to find out y square. We have the equation x minus 2 whole square plus y square is equal to 8. Now if we use this, x minus 2 whole square plus y square is equal to 8. So y square is equal to 8 minus x minus 2 whole square. And we have to integrate y square, so we have to integrate this thing. And okay, so our limits for b and a are the x coordinates of b and a. Now the x coordinate of b was 4 and the x coordinate of a was 0. So we'll use this limit, these limits 4 and 0, 4, 0, and 8 minus x minus 2 whole square. We have to integrate this thing. Okay, now this will be 8x minus x minus 2 plus 1 is 3 divided by 3. We have integrated it, applying the limits. The limits were 4 and 0, and we have to multiply it with pi. Okay, now we have to solve this, and so if you multiply 8 with 4, you get 32. 4 minus 2 is 2. 2 cubed is 8. So this is 8 upon 3 and this is 32. And 32 minus 8 upon 3 is 88 upon 3. So we get 88 upon 3 minus, okay. Then 8 multiplied by 0 is 0. Minus 0 minus 2 is minus 2. Minus 2 cubed is minus 8 and minus 8 upon 3. So we have minus 8 upon 3, which will be plus 8 upon 3. So plus 8 upon 3 and then a minus because this is a definite integral. So 88 upon 3 minus 8 upon 3 is 80 upon 3 multiplied by pi. So we get the answer 80 pi upon 3. Okay. Now this 80 pi upon 3 is the volume of this complete region which I have outlined, including this cylinder. We have to subtract the volume of the cylinder. Now the formula for calculating the volume of cylinder is pi r square h. Okay. Now in this case, we know that this length is, this thing is, its dimensions are 4 units. So if this is a cylinder, this is its height. So the height of the cylinder is 4 and the radius of the cylinder, the y coordinate of a was 2. So this is 2 and this is 0. The radius of cylinder is 2 and the height of cylinder is 4. Okay. So the volume of cylinder is volume of cylinder. The formula for calculating the volume of cylinder is pi multiplied by radius squared multiplied by height. Okay, so our radius is 2 squared and our height is 4. 2 squared is 4. 4 multiplied by 4 is 16 and 16 pi. Okay, so 16 pi is the volume of the cylinder. Now we have to subtract 16 pi from 80 pi upon 3 to find the volume when that shaded segment is rotated. Okay, so the final volume, final answer we get will be 80 pi upon 3 minus 16 pi, and that will be 32 pi upon 3. So this is our final answer. In this question, we have to solve the equation fx is equal to 0, and we have to give the answer in the form a plus b under root c, where a, b and c are integers. Okay, so fx is x minus 4 x raised to the power 1 upon 2 plus 1. We have to equate this to 0 and we have to solve this equation. Okay, so we can actually convert this equation into a quadratic equation, and then we can easily solve it using the way we use for quadratic equation, using the quadratic formula. Okay, so we'll say that, let's suppose a random variable where we can take any variable. In this case we are taking u. Let's suppose u is equal to x raised to the power 1 upon 2. This means that x is equal to u square, and then we have u square minus 4u and plus 1 is equal to 0. Now we can solve this for u using the quadratic formula. Now the quadratic formula is minus b plus minus under root b square minus 4ac upon 2a. So writing the quadratic formula down, minus b plus minus under root b square minus 4ac upon 2a. Okay, so b in this case is minus 4, so we have minus 4 plus minus under root b square is minus 4 squared minus 4, a is 1 and c is 1 or 2 divided by 2a. A is 1. Okay, so now we just need to simplify it. Minus 4 is actually 4 plus minus under root 4 square is 16 minus 4 is 12 divided by 2. Now we can simplify it using a calculator. 4 plus minus under root 12 divided by 2 is actually, this thing is equal to 2 plus minus under root 3. Okay, now this is actually the value of u, but what we have to find is, we have to find the value of x. Okay, now we had assumed that u is equal to x1 upon 2. Okay, so u is equal to x1 upon 2 and u is 2 plus minus under root 3. This means that x1 upon 2 is also equal to 2 plus minus under root 3. Now since there are two equations, since there are two answers, one is 2 plus under root 3 and the other one is 2 minus under root 3. So to remove this 1 upon 2, we will square both sides, and when we square both sides, here we'll have x, and on the other hand, on the other side, we will square this whole thing. Okay, so we can use a calculator for this as well. Okay, so 2 plus under root 3 whole squared will be 7 plus 4 under root 3, and 2 minus under root 3 whole squared will be 7 minus 4 under root 3. So these are the two answers we'll get. We had to show the solutions in the form a plus b under root c, and here we have shown them. Now let's move to the next part. Given that fx is equal toghx, the composite function ghx, find the values of m and n. First we have to find the composite function ghx. Now g is mx square plus n and h is x1 upon 2 minus 2. Okay, we have to find ghx. Okay, so gx is mx square plus n and hx is x1 upon 2 minus 2. X raised to the power 1 upon 2 minus, okay, ghx. Now ghx will be m, then putting x here, x 1 upon 2 minus 2 squared plus n. This is GHX and this thing is equal to fx. Okay, now fx is x minus 4 x raised to the power 1 upon 2 plus 1. X minus 4 x raised to the power 1 upon 2 plus 1. This is fx. Okay, now this thing is equal to m x raised to the power 1 upon 2 minus 2 whole square plus n. Now what we have to do is we have to expand the right hand side. Okay, so expanding the right hand side, we get x 1 upon 2 minus 2 whole square. We'll use the identity here. We'll get x minus 4 x raised to the power 1 upon 2 plus 4 plus n. Multiplying it, we get m mx minus 4 mx raised to the power 1 upon 2 plus 4 m plus n. Now we have to equate this to x minus 4 x raised to the power 1 upon 2 plus 1. Okay, we can compare the coefficients. Okay, so if we compare this x with mx, we can easily find out that we can easily realize that the value of m must be 1. Okay, then if we compare minus 4x raised to the power 1 upon 2 with minus 4x mx raised to the power 1 upon 2, we'll also come out to the answer that m is equal to 1. Then we can compare 4m plus n to 1. Okay, so if we say that 4m plus n is equal to 1, we already know that m is equal to 1. This means that 4 plus n is equal to 1 and n is equal to minus 3. Okay, so the value of m is 1 and the value of n is minus 3. In this question, we have to find the perimeter of the shaded region. The shaded region is this DCE, which is located between two circles and this triangle. The radius of the smaller circle is 5 and this line AC is the radius. So if AC is the radius and this is equal to 5, then AD is also the radius, then it must also be equal to 5. Similarly, the radius of the larger circle B is 8 and BC is the radius. BE is also the radius, so BE must also be equal to 8. Okay, so we can find out DE using Pythagoras' theorem. We know that this length AB is equal to 13 and this DAD is equal to 5. Okay, so 13 squared is equal to 5 squared plus BD squared, and 13 square is 169. 169 minus 5 square is 25 is equal to BD square. Now BD square is equal to 144, and if we take the under root of 144, then we'll get 12. So BD is equal to 12. Okay, so if BD is equal to 12 and we subtract EB, which is 8, we'll get 4. So this means that DE is equal to 4. So one thing we know is DE is equal to 4. Now we have to find the arc lengths DC and EC. One way to find the arc length is to find the angle in radians of DAC and B and CBE. Okay, so we can use basic trigonometry for this. To find out DAB, we can use that. We can say that tan DAB is equal to, okay, so DB is equal to 12 and DA is 5. So we have 12 over 5, and don't forget to use the radian mode. Tan inverse of 12 over 5 is 1.176 radians. So DAB is equal to 1.176 radians. Okay. Now we know that DAB is equal to 1.176 radians. This is a triangle and this is a right angle triangle, so we have an angle which is equal to pi upon 2 radians since this is 90 degree. Now we can also find out dBA. We can say that dBA is basically pi minus pi upon 2, that 90 degree angle minus 1.176. So our third angle is 0.394 radians. 0.394 radians. Our third angle ABD is 0.394 radians. Okay. Now first let's find out the arc length DC. The formula for finding out the arc length is S is equal to R theta. S is the arc length, R is the radius, theta is the angle in radians. So the arc length of the smaller circle, the arc length DC is 5 multiplied by the angle DAC, and the angle is 1.176 radians. So we'll say that the arc length DC is equal to 5 multiplied by 1.176, and 5 multiplied by 1.176 is equal to 5.88 centimeters. Okay, now the arc length EC is equal to 8, the radius is 8, 8 multiplied by the angle ABD, the angle is 0.394 radians. So the arc length EC is 8 multiplied by 0.394 radians. EC is equal to 8 multiplied by 0.394 radians, and 8 multiplied by 0.394 is equal to 3.152 centimeters. Now the perimeter will be DE, which is 4, plus EC, which we have just calculated, plus DC, this thing. So we have to add 4, 5.88 and 3.152. So our perimeter is 5.88 plus 3.152 plus 4. Our perimeter is 13.032, and rounding it off we have 13 centimeters. Okay, let's move to the next part. In this part we have to find the area of the shaded region, the same region that we just calculated the perimeter of. Okay, so we have to find the area of the shaded region. Now an easy way to find the area of the shaded region is to first find out the area of the triangle ABD and then subtract the area of the sectors ACD and DCE from it. Okay, so the area of the triangle ABD is, let's write it down, area of triangle ABD is 1 upon 2 multiplied by base multiplied by height. The base is 5 and the height is 4 plus 8, 12. Okay, so the area is 1 upon 2 multiplied by 5 multiplied by 12. The area is 30 centimeters square. Now the area of the sector, we have to find out the area of the sectors ACD and BCE. The formula for calculating the area of the sector is 1 upon 2 r square theta. R is the radius, theta is the angle between the radius AC in this case and BC in this case. Okay, so for this smaller circle, the area of the sector DAC is 1 upon 2 multiplied by 5 square multiplied by theta, and theta, the angle DAB was 1.176. Okay, so the area of the sector DAC is, area of sector DAC is 1 upon 2 multiplied by 5 square multiplied by 1.176. The area is 14.7 centimeters square, And now we have to find out the area of the sector BCE. The area of this sector is 1 upon 2 multiplied by 8 square multiplied by the angle, this angle CBE. The angle in this case was 0.394. So we have the angle and the radius. Okay. So the area of the sector CBE is 1 upon 2 multiplied by 8 square multiplied by 0.394. The area is 12.608 centimeter square. Now the shaded area of the shaded region, the shaded area will be 30, and we'll subtract 14.7 and 12.608 from it. We'll get the answer 2.692. This is our area, the area of the shaded region. Moving on to the next question. In this question, we are given a curve which has the equation y is equal to k multiplied by 3x minus k raised to the power minus 1 plus 3x, and k is a constant. We have to find the values of x at which there is a stationary point. Okay. So one way of finding the stationary point is differentiating the equation and equating it to 0. So we'll get the x coordinates of the stationary point. Let's do it. Let's write dy over dx and let's differentiate this equation. So we'll write k 3x minus k. Here there is power minus 1, so minus 1 is minus 2 multiplied by the power minus 1 multiplied by 3, and then we have plus 3x, so differentiating plus 3x we get plus 3. Okay, now we'll equate dy over dx to 0. Let's simplify it. Minus 3k over 3x minus k raised to the power 2 plus 3 is equal to 0. This is our differential. Let's solve it. 3 is equal to 3k over 3x minus k raised to the power 2. We can cut 3 on both sides, 1 will remain. Okay, then we have 3x minus k raised to the power 2 is equal to k. If we take under roots on both sides, we will get 3x minus k is equal to under root k. And now solving for here, we'll have plus minus under root k. And now solving for x, we'll get x is equal to k plus minus under root k upon 3. So we have two values of x. One value is k plus under root k upon 3, and the other value is k minus under root k upon 3. These are the two values we'll get of x. Okay. Moving on to the next part. In the next part, we have a function f and it has a stationary value at x is equal to a. We have to find the value of a and determine the nature of the stationary value. So if you look at fx, you can see there is a resemblance between this function and between this equation. The only difference is that here we have k and in fx we have 4 in place of k. Okay, so here we have 4 in place of k. This means that we can use 4 as the value of k, and the differential we got in our previous part can be used as the differential of fx. So we'll say that the differential of fx is the same thing as this, except that we'll have 4 instead of k. So this will be the differential of fx will be minus 3 multiplied by 4 divided upon 3x minus 4 raised to the power 2 plus 3. Okay, so the differential is minus 3 multiplied by 4 is minus 12. 3x minus 4 raised to the power 2 plus 3. This is the differential we'll get. Okay. The function f has a stationary value at x is equal to a. This also means that the stationary value of x will also be the stationary value of a. Okay, so the stationary value of we had these two were our stationary values, and now since in fx we will use 4 as the value of k, so we can use this value as the stationary value of a. Okay, and we are also told that x must be greater than or equal to 3 upon 2. So we'll use this value as we know 1 will be greater than 3 upon 2 and 1 will not be greater than 3 upon 2. So we'll use this one, k plus under root k upon 3 as the value of a. Okay, so a is k plus under root k upon 3 and we'll use 4 in place of k. So 4 plus under root 4 upon 3. Now under root 4 is 2, so 4 plus 2 is 6 and 6 upon 3 is 2. So the value of a is 2. A is equal to 2. And the differential of fx was this thing. Now we have to determine the nature of the stationary value. For determining the nature of the stationary value, we have to find out the double differential. Okay, so we have to differentiate this once again. Writing this down in this form, 3x minus 4 raised to the power minus 2 plus 3. Now if we differentiate this thing again, we'll get minus 12 multiplied by minus 2 multiplied by 3 multiplied by 3x minus 4, and here we have minus 2 minus 2 minus 1 is minus 3. Differentiating plus 3, since this is a constant, we'll get 0 and we won't write it. So minus 12 into minus 2 is 24. 24 multiplied by 3 is 72. 72 3x minus 4 raised to the power minus 3. This is the double differential of fx. We have to determine the nature of the stationary value. Okay. Now if you put the value of a in this double differential, the value of a is 2. So 2 3s are 6. 6 minus 4 is 2. And 2 raised to the power minus 3 is 8. 1 upon 8. If you multiply it with 72, you will get the answer 9. Okay. So we can write when a is equal to 2, the double differential of fx is equal to 9. Since 9 is greater than 0, we can say that this is a minimum point. The nature is minimum. In the third part, we have a function g, and we have to determine whether g is an increasing function, a decreasing function, or neither. Okay. So if you look at this function, you can see that there is a resemblance in gx and the first part. Here, instead of k, we have minus sign, which means we have minus 1 instead of k. And instead of 3x minus k, we have 3x plus 1, which means, if you look at this, okay, so this means that in the third part, we can use minus 1 as the value of k. Okay, and we can also use this differential for gx, minus 3k upon 3x minus k raised to the power 2 plus 3, and we'll put minus 1 in place of k. Okay, so we can write that gx is equal to minus 3 multiplied by minus 1 is 3, and 3x plus 1 raised to the power 2 plus 3. Okay, so we used minus 1 as the value of k, and we got this as our answer when we differentiated gx. And we are told that x is greater than or equal to 0. Okay, so now you can see that when x is greater than or equal to 0, the denominator, this fraction, will always be positive for x is greater than or equal to 0, and obviously plus 3 will remain plus 3. What this means is that the differential of gx will always be positive. And what is the differential of gx? The differential is of a function is its gradient, and if a gradient is positive, this means that it is an increasing function. Okay, so we can write that gx will be greater than 0 or will be positive for x is greater than or equal to 0. So it is an increasing function. Increasing function.